Alright, welcome back. This is our last lecture for week number 3. We'll be looking at energy balance. And this is also really our last lecture heavy week. It's sort of front end loaded, and then the rest of the term we're going to be focusing on the book. So this week and last week we looked at macronutrients. We've gone over some of the very basics of energy balance already. You know that our body's metabolism can cope with quite a lot. When your diet does not give your body enough energy, or too few carbohydrates or too little protein, your body uses its lipid stores to meet energy needs. It will degrade your lean tissue, your muscle mass, to meet glucose needs. And when your diet gives your body too much energy, then the body can store that. It can transform it and store it as glucose, but mostly as lipid stores. So whether you are taking in an excess or a deficiency of energy, we're talking about a change in body composition, and specifically in body fat storage. That change is a result of energy imbalance. So the formula is very simple. People who consume more food energy than they expend store that excess energy as body fat. People who expend more energy than they take in reduce their body fat stores. But people who consume too little energy to support their body's activities have to rely on both fat and muscle, lean body mass stores, right? So it's all about finding a balance, which sounds very simple, but can actually be fairly complicated. The basics of energy balance. You are continuously expending energy. Your body is using energy right now to maintain, to grow, to think, to see, to listen. Your cells are dividing. Your heartbeat is regulated. Your blood is flowing. But you only eat on occasion, despite the fact that your body is constantly using energy, right? This continuous work that your body is going through. Ideally, your energy intake covers the energy costs of energy expenditure. Makes sense. But with little, if any, excess, right? Excess is stored as fat and glucose. But that doesn't mean anything bad, necessarily. Even healthy adults have and should have stores of energy, fat and glucose. It helps to feed your body in between meals. And the amount of fat that you deposit into your body or take out of your body's stores depends on energy balance, right? On today's energy balance, on tomorrow's energy balance, on a day-by-day balance. So energy balance is the amount of energy consumed, intake, versus the amount of energy expended, metabolic processes and physical activity. Although the calculation is rounded, which doesn't really matter unless you're a nutritionist, and some of you are, the general rule is that for each 3,500 kilocalories you eat in excess of your daily energy requirements, your body stores about 1 pound of fat. And for each 1 pound of fat lost, you need to expend 3,500 kilocalories of energy above and beyond the number of kilocalories that you have consumed. And that is known as the 3,500 kilocalorie rule. Again, listen to what I just talked about in the last slide for a definition of that kilocalorie rule. We've been using this as a rule for the last 50 years or so. And when you think of what a rule is, you probably think of something that is absolute, that is deterministic, that is defined, right? You can put walls around that. This idea that it's a cookie cutter solution, which is a nutritional pun. Anyway, the 3,500 kilocalorie rule has some significant limitations. It's not this blanket solution. First, and maybe most important, as one person, as an individual, begins to lose weight, the body adapts to a reduced kilocalorie diet, and the deficit in energy that one person would need in order to continue to lose weight increases. So from 3,500 for 1 pound to 4,000 to 4,500 in terms of exercise and energy expenditure, right? And at a certain point, that is going to have diminishing returns, right? It will start to have negative effects on the body because of the lack of nutrients in the body or the excess of exercise over training, which is exactly why it needs to be a balance. It's not just food and it's not just exercise. It should be both things together, right? No matter how you approach weight gain or weight loss, quick, rapid changes in the body in terms of body weight are not good. These are not simply a change in your body's fat stores, but mostly in your body's fluids in terms of a rapid change, and partly in the lean tissue and bone material, so muscles and bone mass. If you recall, water constitutes about 60% of your body weight. So if you dehydrate your body, you rapidly gain or in this case lose weight. But if you want to lose fat or gain mass, that is a much more gradual process. It's not an overnight thing. It's not a quick day or a week solution. You're talking about slow changes over a long period of time. Let's get back to energy balance, and we'll start with energy intake. The intake of food energy, or kilocalories in food. We talked briefly about food composition already, right? So to find out how many kilocalories that food actually provides, how do we do that? Well, we can burn the food in a controlled space. It's called a bomb calometer. And this is an instrument that measures the heat energy released from food when food is burned. Because when you burn food, energy is released, right, in the form of heat. And the amount of heat given off provides a direct measure of the energy in that food. Now remember, kilocalories are energy, right? But more exactly, they are heat energy. You can also figure out how much energy is in foods based on the weight of each macronutrient per serving. For example, if you know that a food has 12 grams of carbohydrates, how many kilocalories is that? And you know the answer to this, right? Because you know how many kilocalories is in 1 gram of carbohydrates. That's 4, right? 4 kilocalories. So 12 grams of carbs times 4 equals 48, right? That's 48 total kilocalories. If you have 5 grams of fat, how many total kilocalories is that? Well, in 1 gram of fat, you get 9 kilocalories, right? Remember? So that's 5 times 9, that equals 45. 8 grams of protein, how much is that? 8 times 4 equals 32. Next is food intake. Now, when you think of food intake, most likely you think of food. But food intake is more complex than that. Somehow, the body decides how much and how often to eat, right? I mean, when to start eating and when to stop. How does it know how to do that? And it's based on a number of signals, environmental signals, genetic signals. We might call that appetite, which is essentially our body's response to the sight, the smell, the thought, the taste of food, which initiates or delays eating. So let's start with hunger. We eat for a variety of reasons, right? We kind of touched on that in your introductory posts, which was really cool. But one reason that will link everyone in the class together is we eat because we are hungry, right? In our body, hunger is the physiological response to a need for food that is initiated by nerve cells and signals and chemical messengers, which are proteins, right, from the brain, mostly from the hypothalamus. That isn't just happening in your brain, however. It might create your stomach to growl, for example. Your body is telling you, and that starts in your brain. That process that gets you thinking about food and the idea that I'm hungry or I'm not hungry, that can be influenced by so many different things. The presence of the absence of nutrients in your bloodstream, right? The size of the meal that you just ate, the types of food in that meal, the customs involved in eating, the climate. Is it hot outside? Is it cold outside? Your physical activity or the physical activity that you've been involved in throughout the day. Hormones and hormone cycles, illnesses, etc., etc. And if we just take hunger from the perspective of the stomach is designed to handle a certain amount of food, right? But only during a particular time, right? I mean, you can't continually put food into the stomach, right? So periodically it can handle a certain amount of food. And many people, not everyone, typically eat at about 4-hour intervals, because at 4 hours after a meal, most, not all of the food, but most of the food has been digested and has left the stomach. The next two components of food intake are satiation and satiety. Satiation is, if you're eating food, the food is entering your digestive tract, it's in your stomach, it's being digested in your intestines, and satiation begins. This is the stretching of the lining of your stomach and the releasing of hormones. There are receptors in your stomach that detect when your stomach begins to stretch. It's an organ. It stretches after each meal or with each meal. And when it stretches to a certain amount or stage, which is going to differ according to individual and food and environmental factors, when it reaches that stage, whatever it is, it releases a hormone that makes you feel full and you stop eating. But that hormone decreases in your blood over time. I mean, much faster than it actually takes a person to digest the food. And people should begin to feel full or to feel hungry again after about 30 to 45 minutes, but most people don't. And that's because the feeling of satiety, the next one, continues to suppress hunger. It tells your body not to continue eating. And this is partly the communication between nutrients in your blood and your brain, the hypothalamus, because once the nutrients decrease to a certain level, your brain is going to send out those signals to eat again. Now, you might be thinking about your favorite meals, right? And you can override these hormonal responses, and you can simply eat more. And people do, especially in response to a number of clues or factors, like your favorite food, or a sweet dessert, or stress, or simply the availability of food, having food in larger portion sizes, or a food memory that you might have, or whatever it happens to be. The degree of satiety depends partly on the nutrient balance of the meal that you're eating. If you eat a meal that is high in sugars and carbohydrates, but maybe not much else, Your body will feel full for a while, but it will soon begin to call out for more food because you also need lipids and proteins, right? Some of the foods that give your body a lasting satiety are like fibrous foods, because if you remember what we talked about, fiber slows digestion and passage, and therefore it slows down nutrient absorption. A bit of food for thought on that note. What did you have for dinner last night? Or maybe you're listening to this while you're cooking or eating. When did you or do you stop eating? Is it when everything that you cooked is finished or on your plate is finished? Do you usually finish everything on your plate? And why? Or why not? Here's another example. Which of these two situations would best describe how you eat? You're at home, you're in your comfortable clothes, you're watching Netflix, and say you're eating some chips, whatever kind of chips. Maybe they're potato chips, or maybe they're cassava chips, or whatever it happens to be. And you're watching one of your favorite shows. Maybe it's a new episode, and you've been waiting for this episode, and you've been working hard at your job and at school, and you're just eating chips, right? And you eat those chips without really thinking about it until the show is over. Or say you're in the same situation. You're at home in your comfortable clothes watching Netflix, and you're eating chips, but you only take a small handful and you put them into a bowl or something like that, and you only eat those chips just to satisfy that initial hunger craving, right? So you put the rest of the chips away even though the show is still going and you're still watching the show. Which one of those would describe you best, the first one or the second one? What causes us to stop eating? 54% of adults in the United States admit to finishing everything on their plate, regardless of other components involved in eating a meal. Let's change topics. Let's explore energy expenditure. If you measure the energy in food as heat, then how do you measure the energy being used by someone? Well, you also measure that by heat. When your body breaks down all the macronutrients of anything that you're eating, heat is generated and released, and the generation of that heat is called thermogenesis, and that can be measured to determine the amount of energy that the body expends. Now, I'm not going to go over the methods in this online course because we just don't have time to do that. We're just going to look at some of the basic components. The total energy a body expends reflects several categories of thermogenesis. So we'll look at some of those broadly: basal metabolism, physical activity, and food consumption. Starting with basal metabolism, about 2/3 of the energy that an average adult uses in a day goes just to support our body's basic needs, the basal metabolism, metabolic activities, like our lungs are inhaling and exhaling. Your bone marrow is making new red blood cells. Your heart is beating, right? It's beating like 100,000 times a day. Your kidneys are filtering all of the waste products. So all of these basic processes of life. I've got a definition up on here which you can read. The energy needed to sustain life when a body is at rest, including digestive rest, physical rest, and yes, emotional rest. The basal metabolic rate is the rate at which the body expends energy for all of these life-sustaining activities. And that rate varies from person to person, and it can also vary for that individual person with a change in lifestyle, for example, physical condition or environmental condition, whether it's hot or cold outside. And we can measure the basal metabolic rate, or the BMR, in a person after generally a 12-hour rest and fasting in a room that is at a comfortable temperature. And next is physical activity, the voluntary movement of your body, your skeletal system, your muscles, support systems. Physical activity is the most variable and the most changeable component in regards to energy expenditure. And it's because of that it is also one of the most influential for weight gain or weight loss. During physical activity, our muscles need energy to move, and our lungs and heart need extra energy to help deliver all of those nutrients and oxygen to our muscles, and then to remove all the waste products that we are creating. The amount of energy needed for any activity, whether it's playing a sport, basketball or running or biking, whatever it happens to be, even studying for a quiz, depends on our muscle mass, our body weight, and on the activity itself. The larger the muscle mass of an individual, the heavier the weight of the body part that an individual is moving, the more energy that's going to be required, the more absolute energy, right? The more energy, therefore, that is expended. Also, the activity itself, the intensity, the duration, the frequency, all influences energy expenditure, because the longer, the more frequent, and the more intense the activity, obviously, the more kilocalories that you use. One of my favorites is the thermic effect of food. When we eat, our digestive tract, our gastrointestinal tract muscles need to contract in this rhythmic sort of a way, and that helps to move food through our body during digestion and absorption. That rhythmic movement speeds up when we eat, and the cells that manufacture and secrete digestive juices become active. And some nutrients, because our body needs to use energy to absorb nutrients, right? All of this means energy. Your gastrointestinal tract is working hard. Your body is producing more heat simply to digest and absorb and move that food through your body. And that heat is known as the thermic effect of food. And thermoregulation. You can actually keep your body at a certain temperature. Not all organisms can do that. And we can do that despite our environment, even if the outside environment is not at that ideal temperature. This is homeostasis, or a type of homeostasis. It is the long-term maintenance of homeostasis through balancing heat gain and heat loss. Now, it's much more involved than that. We're just going to touch on this in basic. It's about maintaining the core temperature of approximately 37 degrees Celsius. And how do we do that? Well, there's the generation of heat through metabolism. Heat is a byproduct of the metabolic conversion of food into energy, and maintaining that balance. So exchanging heat within our bodies and between our body and the environment. So it's transferring heat within the body from internal organs to the skin, and then mechanisms that allow us to either gain or lose that heat to the environment, right? If it's cold outside, we reduce the heat that's being transferred to the skin. If it's hotter outside, or we're involved in physical activity, we increase the amount of heat that we push towards the surface of our bodies, because that is where heat is exchanged. In addition to all of these aspects of thermogenesis, we also have growth, reproduction, pregnancy, and lactation. And this requires energy. Growth is primarily referring to younger individuals that are still growing, the addition of new tissues. For example, in the first year of life, an infant triples their birth weight and doubles their birth height. That takes an immense amount of energy. pregnancy, reproduction, the growth of maternal tissues, and the fetus takes an immense amount of energy, let alone the costs of then carrying that child in the womb and then after birth for many mammals. And lactation. The production of milk requires an extra 500 up to 1,000 kilocalories a day. That's a significant impact to energy expenditure. How do we actually estimate energy requirements? And that is not so easy. We do that on an average basis. We look at mediating factors, the average, the mean. But in fact, there is a lot of individual variation, and that's based on a number of possible components. The DRI committee develops equations based on research, and you can look at those online. That's partially integrated into the Energy Balance Project if you decide to go with that. But those equations are based on some important factors, and first is sex. Females have a lower basal metabolic rate than males, partly because males tend to have more lean body mass. Now, this isn't the case for everybody. There's variation involved, which complicates things. So we're just looking at generalizations. I've added gender up there as well. Sex and gender are not the same thing. In biology and in paleo or bioanthropology, we are often studying sex, what your genes say about you in terms of reproductive anatomy, or sex and gender, which gender would be more about roles or perceptions, culture, not genes specifically. Growth, obviously the basal metabolic rate is higher in people who are still growing, and that means not just infants or children, but juveniles. And probably most of you out here listening to me are still growing too. If you are younger than the age of 25, there is more than likely one bone in your body that's still growing and still is not fully fused. That's the clavicle, and if you're interested in that, you'll have to take more anthropology courses. And growth can also refer to aspects of reproduction, pregnancy, and lactation, which also deal with components of growth. Next is age. The basal metabolic rate declines with age, because in part so does lean body mass. And that's partly related to a decline in hormonal activity, which affects body weight and metabolism, and a decline in physical activity. And of course, there is physical activity. Now, we get all of these recommendations for physical activity, the DRI, for example. That's more of a blanket recommendation for a population. It doesn't encompass all of the nuances. It's not very specific. If you want to get more specific, you would have to look at your own energy output and intake. And you can do that in the Energy Balance Project. Basal metabolic rate also increases with mass. And when I say mass, I don't just mean weight. Some of us may default to that, but I mean entire body mass. So height and or weight, because there is an increase in surface area, which is related to thermoregulation. If you want to look at that in more detail, feel free to come and talk with me or take some other anthro classes. If you increase surface area, whether by height or by weight, that means you need to account for that and how that impacts thermoregulation. And that means more energy expended. In that same vein, let's briefly look at this trend of body weight and composition, which are two different things, even though we tend to equate them to the same thing all too often in this society. Say a person that's 5 feet 10 inches, right, maybe weighs 150 pounds. That person may only carry 30 pounds of fat. The rest of the person, 120 pounds, is mostly water and lean tissue, so muscle. organs, hearts, liver, etc., bones as well. That is your body composition, which is why we cannot directly measure someone's body composition, right? At least in a living person. And that's why researchers assess body composition indirectly. And that assessment is based on this assumption that we have on the screen, that body weight equals fat plus lean tissue plus water. And why is this important? It's important because weight gain or weight loss tell us nothing about how your body composition has changed. Now yet, still, people view weight as a measure to judge their leanness or their fatness. The misconception is that overweight or fat equals overfat, which is not always the case. It's not necessarily the case. I remember hearing, I grew up in Colorado, and I grew up watching the Denver Broncos, which, if you don't know the Denver Broncos, doesn't matter. A football player named Carl Mecklenburg, who was a really popular player for the Broncos in the 80s. And I remember hearing him say in an interview once that on the field he was considered a superior athlete. But once he took off his uniform, on the street, he was just some fat guy. And once I heard that, it made me think about perception. Like, why was he fat in one context but athletic in another? Now, this is an individual who is not unhealthy, and an individual who has very little body fat. But he's not referring to composition, is he? He's referring to weight. That's what he's referring to. Now, on the other side of the coin, this also works. Someone might appear to be a healthy body weight, but they may actually be carrying more body fat than average, or that is healthy. And what that means is that suddenly there is that hint of perception and culture and bias and perspective in this class, which we're going to be focusing on for the rest of the term. How much should a human weigh? How much should a man or a woman weigh? How much should a male or a female weigh? What is the ideal weight? How do you know if your weight is appropriate for your height, or if it might be jeopardizing your health, right, on either end of the health curve? Now, those questions are fairly straightforward, and clear questions would seem to predict clear answers. But guess what? The answers are pretty complex and variable depending on what source or what person or what professional you ask. So we'll take a brief look at some of these general perspectives. We'll start that with the criterion from fashion. If you ask people what is ideal in terms of body shape or body weight or body composition, most people will turn to their friends or to the media for answers and judge weight by appearance. Our society sets what is fairly unrealistic ideals for body weight, and especially for women. You can see this in magazines, in movies, and TV, and ads on the internet. The narrative of our society, the skipping record of our culture, blares that message to us every day. To be beautiful, to be happy, is to be thin. So media has this powerful influence on weight concerns and dietary concerns, on nutrition. One of the many intriguing aspects of that influence is the perception of our own body images. And those perceptions may have actually little to do with real body weight or size. People of all shapes and sizes and ages have learned to be unhappy with being overweight, from supermodels that may struggle with anorexia nervosa to fitness trainers who feel they need to look a certain way, right? Even Carl Mecklenburg, who I talked about a couple slides ago. That dissatisfaction all too often leads to damaging behaviors for our bodies. So one of the first steps to making healthy changes is often self-acceptance, and understanding that fashion is a fad. Body shapes that are valued change with time and change with culture, or between cultures. It's different between cultures. The standards that define what is ideal are entirely subjective, and in many cases have very little in common with health. Which brings us to the second criterion, the criterion of health. We should be at a state of awareness and understanding to see that fat is not simply acceptable, but fat is normal. Fat is beautiful, but we're not there yet, right? Even if we were there, obesity is different. Obesity is a health concern, and it is a major risk factor for several life-threatening diseases, including the #1 killer in the US for adults, heart disease, as well as diabetes and cancer. What I'm trying to say is that the most important criterion for determining how much a person should weigh and how much body fat a person needs is not appearance. It's not appearance. It should be good health. So a person has enough fat to meet the body's needs, given everything that we've talked about, but not so much that the body is being placed at risk. And that range of a healthy body weight or amount of a healthy body fat is identified using a common measure of weight and height. And it's called the body mass index, or the BMI. Again, this isn't as precise as it can be, but it gives us a blanket formula that we can use at the population level. It's a measure of a person's weight relative to their height, and you divide your weight by the square of your height. Now you can do this, you can incorporate that into your energy balance project if you want to. But I'll show you a chart on this in the next slide. Here is a chart that will help you calculate your BMI. You just need to find, you can do this estimated wise, or you can actually take measurements. But I'm guessing many of you know about what height you are and about your weight, give or take. So you can do this. It doesn't have to be accurate, or you can make it very accurate and include that in your energy balance project if you decide to do that. If you look at the very top of the chart, you'll see your approximate BMI. And that's broken down into 4 regions. First is underweight, and then healthy weight, and then overweight, and then obese. And you can see the healthy weight is between 18.5 and 24.9 BMI. That's important to know. In the United States, more than 2/3 of all adults have a BMI that is greater than 25. Now, not all of those people are unhealthy, but many of them are. Keep in mind that BMI reflects height and weight values. Again, it's not actually reflecting body composition. And body composition is affected by so many factors that we've talked about: genetics, sex, gender, physical activity, growth, ethnicity, age, environments that we grew up in, environments that we live in, the work that we do, etc., etc. So using BMI as a standard across cultures and for all peoples doesn't really work. We have to take into account individuality and actual people, but this is the standard. It's something that we can use quickly and easily to understand and adjust health goals and human variation. Let's do another thought experiment. Now, go back to the last screen and calculate your BMI, or look for a formula online or a chart online if you can't see that chart very well, and calculate an approximate BMI for you. Okay, so you have that number. You can write that number down. In this experiment, I just want to highlight how figures can be used to determine how accurately people perceive their body shape in relation to their BMI. So here on the screen you're looking at a number of figures that have different body shapes. Go ahead and point to or pick out the one that you feel best reflects your body shape, regardless of your BMI, the one that you think best reflects your body shape. Now, keeping your BMI in mind, underneath this I revealed the average BMIs for individuals with a body shape that are in average comparable to those images. Did you get it right? Did you overestimate things or underestimate things? Many people in the US or in Western societies in general, with that fashion image of body shape that we get, tend to overestimate their weight or their shape based on these images, right? Or in some cases underestimate. Majority overestimate because you're seeing things through that fashion lens. In some cases you might underestimate, but your actual composition is healthy and you're carrying maybe more lean mass. For example, Arnold Schwarzenegger. Arnold Schwarzenegger, when he won Mr. Olympia, had a BMI of over 31. If you go back to the chart, that's considered obese. Now, 31, based on this chart, would give a different body image than Schwarzenegger actually has, right? He was not obese. He is actually very healthy. The last major concept I want to talk about this week is health risks and body weight and body fat. Because body weight and body fat percentage correlate with health risks and life expectancy. The correlation relates to the likelihood of developing certain chronic diseases and therefore shortening of life expectancy for those with either a higher BMI and an increased fat, especially visceral fat, or a lower BMI in terms of body composition. Now, correlations, as many of you know or you might remember from your math or stats classes, correlations are not causes, right? Having the perfect body composition and the perfect weight for your height does not mean that you will never be diagnosed with a chronic illness or that you will live a long life. There are a number of things that can happen, right? Including accidents. Similarly, having a BMI that puts you at risk does not mean that you're going to have a shorter lifespan or that you will ever be diagnosed with a chronic disease. But, having said that, people with a BMI between 18.5 and 24.9, which we talked about, tend to have fewer weight-related health risks, and those risks increase as BMI either falls below or above those values. Again, keep your common sense caps on. A person can have a healthy BMI and body fat percentage, but drink and smoke, which jeopardizes your health, right? A person with a BMI of 33 might have a high percentage of body fat, but that person may also be walking for an hour or two every day, and maybe that person eats fairly healthy, which both of those things are improving health, right? So that person is actually more healthy, even if there are not significant changes in body weight or body fat. Once you fall below 18.5, you put your body at health risks. That can be due to malnutrition, it can be due to substance abuse, it can be due to illness or smoking, whatever causes a person to drop below 18.5. And of course, we're not talking about people who would be considered underweight in terms of a BMI but are actually active and healthy. Being underweight your body lacks adequate access to nutrients, and that can become a serious issue, especially if a person is dealing with a disease. Your body doesn't have the nutrients and the energy it would need in those cases to fight that illness. Surgery might not be an option for individuals in this situation. Underweight, reproductively active females often develop irregularities in terms of the menstrual cycle and can even become infertile. Underweight females that conceive often give birth to underweight and in some cases therefore unhealthy infants, which is why fat and increased weight is a really good thing for females planning to conceive, despite what all of these fashion images tell us. On the other end of the scale, there are also health risks. And a lot of these you probably hear about in terms of news reports and media. In fact, there are so many health risks that excessive body fat has been designated a disease, obesity. And the health risks are more than I've got up here listed. You don't need to know all of these necessarily, just in general, that there are health risks. Some of the ones that you probably heard about are diabetes, hypertension, cardiovascular disease, sleep apnea, osteoarthritis, cancers, gallbladder disease, kidney stones, respiratory illnesses, infertility, complications in surgery, complications in pregnancy. Obesity is second only to tobacco in causing premature death. Alright, let's go ahead and stop there for this lecture. There is so much more that I would like to talk about and include in each of these subtopics, but it just gets to be too much, and so I've had to make a lot of cuts. If you're interested in one of these topics, come and talk with me or with Anna, and we'd be happy to wrap with you. Okay, remember that we've got a quiz this week, and remember to keep fit. That body weight and body composition by themselves do not tell you everything, and should not tell you everything. That making healthy decisions is as important. Being physically activity means that you're promoting health, and that means you're promoting a healthy lifestyle. Okay, we'll see you next week.